So last time we saw for the first time what true two-dimensional waves look like in a circle, and that will be important because we are going to use that as a model for what waves will look like in a sphere, and spheres are important because atoms are spherical. So we're going to be looking at 2 and 3D waves. We saw then the motion on the drum, which is on a circle, and we're also going to learn some names. We're going to learn some nomenclature. The first nomenclature we want to learn is the node. The node is where in the interior of the wave. In the interior of the wave, it's not moving. So let's look at a wave that we know from last time, the 1s. And here's a movie of the 1s. And where in the interior of the wave is it not moving? Just put in the chat. Is there anywhere in the interior of the wave the 1s is not moving? Put it in chat. So, no, the only place it's not moving is on the exterior of the wave, and so 1s has no nodes. Let's compare that to 2s. We're looking where in the interior it's not moving. Is there anywhere in the interior of the wave that it's not moving? Here, I'll put in chat, and you can think of anywhere in the interior of the wave. We're going to play it another time. And there's a ring in the center, a circle in the center where it's not moving. And you have to concentrate, and you can see it. I'll just play it one more time so you can see it. Yep, it's just not moving that circle. And therefore, 2s has how many nodes? Put it in chat. It has one node because it only has one place where it's not moving in the interior. And because it forms a circle or a spherical shaped node is called a radial node. So if there's any circle or sphere where things aren't moving, it's a radial node, and 2s has one radial node, and 1s has no radial nodes. And that's the general feature we're going to discover. Radial nodes will always increase the number. Radial nodes will not change the letter. They will increase the number. Okay, let's look at some more stuff. Besides radial nodes, there are other kinds of nodes. Let's look at 2p. So here's a movie of 2p. So 2p there's places where it's not moving, but is that in a circle or a sphere? Let's play it again. And the answer is it's not a circle or a sphere where it's not moving. It's not moving in a line. See that line where it's not moving? It's indicated underneath. And it turns out if it's a line where it's not moving, or a plane where it's not moving, or even a cone, it all happened in 3D, a cone where it's not moving, these are called angular nodes. And 2p has one angular node. How about 3D? How many angular nodes does it have? Here, I'll play it again. How many angular nodes? Put it in chat. So 3D has 2 angular nodes because there's 2 lines where it's not moving, and that's 3D. Put in chat, how many radial nodes does 3D have? And how many radial nodes does 2p have? Put that in chat. Radial nodes are the places inside where it's the circles and spheres where it goes to 0. So there are no radial nodes in 2p or 3D, but 2p has one angular node and 3D has 2. And remember, and now we'll go on. Okay, so that describes the nodes, and the nodes are wonderful because all the action happens between the nodes. So here's the 3D. I've drawn the nodes, and nodes are where it's 0. They separate the positive regions from the negative regions. To go from positive to negative, you have to go through 0 a node. And so if we were going to consider the 3D a wave, there will be 2 regions shown in blue that are positive, and 2 regions that are negative shown in white, which of course oscillate back and forth in time. And that's where the electron is actually moving. That's where the wave of the electron really is. And the thing in blue is called the atomic orbital. So when chemists want to draw the 3D wave for the electron, They draw the thing in blue, and they call it the 3D atomic orbital.